All right, so here's the first solution that we'll look at. So we're solving the equation negative 1/5 w minus 7/3 is equal to negative 5/2. So this kind of is a perfect storm. It's got three negative coefficients. All three of them are fractions. So there's a lot to talk about here. So in this person's solution, the first step that they did was they looked across the denominators 2, 3, and 5, and they decided that 30 would be a good number to multiply both sides by in order to clear denominators. Why 30? Where did 30 come from here? Right, we just multiplied the three denominators together. Since these three denominators also don't have any factors in common, 30 is also the smallest number that we could use to make this clearing of denominators happen. So not only will the method of just multiplying all the denominators together always work, it also is the simplest way to achieve this. So multiplying both sides by 30 is a way to get forward. And when that happens, 30 multiplies negative 1/5, the first coefficient here, and by swapping those two denominators with one another, we can make that arithmetic simpler. It becomes 30 over 5 times negative 1 over 1, and that's negative 6. The same process when we apply 30 times negative 7/3 gives us negative 70, and 30 times negative 5/2 gives us negative 75. Yeah. The question was, if there was a smaller common multiple that we could use for the denominators, could we use that instead? And the answer is absolutely, right. It just so happens in this example that the smallest common denominator we could use is 30. We could use a larger common multiple. We could multiply both sides by 120 or by 3,000 or something like that. It would also have the effect of clearing out the denominators. It would just leave us with some bigger whole numbers to work with afterwards. But yes, if there is a smaller common multiple of the denominators that we could use, rather than just multiplying the three of them together, then we could do that. And that could give you a little bit less large whole number arithmetic to do. But in this case, we're kind of stuck with the product being the smallest option because 2, 3, and 5 have no factors in common. So once we get down to this equation, negative 6w minus 70 equals negative 75, now we can kind of go on cruise control, right? This is the kind of problem that we attacked with confidence at the beginning of last Monday's class. Just reverse the order of operations. Add 70 to both sides, divide by negative 6 on both sides, and then end up with a solution. W equals 5/6. So that's a straightforward application of the method of clearing denominators. I want to look at one other way that I saw somebody approach this problem that has the same content in it but kind of approaches it from a different philosophy. Let's take a look at the slightly different but equivalent way to look at clearing denominators. And I like this because this alternative way gives us another reason to believe why this works. So when we call it the method of clearing denominators and we go looking for a denominator which is common to all three of these fractions, in other words, a multiple which is a common multiple of 2, 3, and 5, that's the same process that we would need to do if we wanted to find a common denominator for all three of these fractions for the sake of trying to add these three fractions to one another, for example, right? If I wanted to add 1/5 and 7/3 and 5/2, the first thing I would ask myself is, well, what's a common denominator I can put all three of those fractions on top of? And so this alternate solution actually uses that kind of reasoning. So here's how the alternate solution looks. First, identifying that 30 is a common denominator that we can use for all three of these fractions. This solution then rewrites each of those fractions using 30 as the denominator. So here, negative 1/5 gets written as a fraction with 30 in the denominator by multiplying top and bottom by 6. So that becomes negative 6 over 30. Same thing with negative 7/3 becoming negative 70 over 30, and negative 5/2 becoming negative 75 over 30. So here it's a different looking first step, but that number 30 is still playing a really important role. Rather than playing the role of the thing we multiply by in step 1, it's playing the role of the denominator that we rewrite all these fractions in terms of in step 1. And what's good about that is that what's the step that's happening from this line to that line? What's actually happening here? To go from this equation, negative 6 over 30w minus 70 over 30 equals negative 75 over 30, to go to this equation there. What's the actual arithmetic that connects that line to that line? Multiplying by 30, exactly. So that reassures us that this person has still done that multiplication by 30 that the first solution did in step 1. But what's nice about this is that multiplying this equation by 30 is an almost brainless operation to do, because what survives when we multiply these three things by 30 is just the numerators. Negative 6w minus 70 equals negative 75, because the multiplication by 30 has canceled out each of the factors of 1 over 30 present in those three coefficients. So it front loads, again, a little bit more of the work, right, to rewrite these fractions in terms of a new denominator, a new common denominator. Okay. But then once that work has been done, multiplying this equation by 30 is a transparent process. Right? It ends up just canceling out all of my 30s and giving me negative 6w minus 70 equals negative 75. And from there, the rest of the steps were the same, although there was a sign lost right here in the process of copying negative 6w down to the next line. So I will take the liberty of adding that back in. Negative 6w. And then dividing by negative 6 on both sides, we do end up with 5/6 as the solution to this equation again. So again, both of the methods that we just saw are completely equivalent. But I like this, that the second approach shows us why the first approach works. Right? It's because what we're secretly doing is we're re-expressing each of those fractions using that 30 as a common denominator, and then multiplying by 30 to wipe all those denominators off the map. And once we're there, we're in our happy cruise control, reverse the order of operations, whole number arithmetic land. And that's the best land that we can hope for in this chapter.